Hello, now we are going to look at some word problems involving fraction equations. So we'll be given a story and we have to take the parts of the story and write down an equation, and these particular equations will involve fractions of one sort or another. So what we're going to do is try and highlight any key pieces of information and write down what we figured out as we go. So we might have some rough work under here before we actually start the question proper to keep track of what information is being given to us. Because we already know how to solve fractions with equations. Our difficulty here, our challenge here is, can we take this English and identify it and translate it into an equation? So half a number is added to 2/3 of the next consecutive whole number and the result is -4. Find the number. So I have half of a number. Well, if I don't know what this number is, I'm going to call it x. So I've got a number. And then I'm told about 2/3 of the next consecutive number. Well, what does consecutive mean? Consecutive means the next number in a particular group. So if we're dealing with whole numbers, as we're told we are here, if I had 10, the next consecutive whole number would be 11. If I was dealing with even numbers and I was at 4, the next consecutive even number would be 6. So it's the next number in a group. So if I am at x in the whole numbers, like I was at 10, how do I go from 10 to 11? How do I describe the next consecutive whole number? Well, it would be 10 plus 1. If I was at 13, it would be 14. That would be 13 plus 1. So if I'm at x, then it would be x plus 1. So my next consecutive whole number is going to be x plus 1. So I now know how to describe the two numbers that are talked about in this English. I'm told half of my first number, of the number x, is added to 2/3 of the next consecutive whole number, and that when I add those things together, I get -4. So now I can write down my equation. Half of x, so half of x plus 2/3 of the next consecutive number. Well, I now have written down that that is x plus 1. So 2/3 of x plus 1. It's, I suppose, technically in brackets as well. And the result of adding those two together is that I get -4. So I've now translated this big block of English into an equation. And now I need to solve that equation. Now, normally I don't do sums with half of something and 2/3 of something. I write them as fractions. So this is x all over 1, and this is x plus 1 all over 1. So I multiply numerator by numerator, denominator by denominator, and I end up with 1x all over 2 plus 2 on x plus 1 all over 3 is equal to -4. That's in an easier to deal with form. Now there's no simplification I can do to any of my fractions, so now I just need to get the lowest common denominator, which in this case, well, the denominator here is 1 because it's a whole number. So my lowest common denominator is just going to be 6. So I have 2, 3, and 1 as my denominators. Lowest common denominator is 6. So I need to get 6 as my denominator for all of my fractions. So I need to multiply here by 3 over 3. I can multiply here by 2 over 2. It will leave me with 2 steps of multiplying. So ideally, I would actually multiply this out and simplify this first. I think I will actually step back and do that. So I have done this in 2 separate steps because the chances of making an error if I started trying to multiply here by 2, I might miss a 2, make a mistake that is very easily avoidable if I simply go step by step. So it's important not to be in a rush and to actually do things out step by step, and this minimizes the chances of us making an error. Particularly in an exam, it is very easy to make errors, like only multiplying by 2. If we tried to do this step, multiplying by 2 over 2 here, we would end up accidentally only multiplying by 2 instead of what we wanted to do, which is effectively multiply by 4. So taking things step by step and not being in a rush, being willing to put in the extra line to keep our thinking clear, is very important when we are doing more complicated algebra. Any algebra really, but particularly this, where it's getting quite complicated. Now we have everything over 6. we are able to compare like with like. So we're able to add up our numerators, and this is adding all of the top line. It's a plus in this case, so we don't really need to worry about changes of sign. But we can put it in brackets so that we're thinking clearly about what we're doing. So we end up with like terms added up here. So we have 7x plus 4 all over 6 is equal to minus 24 all over 6. I'm now able to compare like with like. I have a single fraction is equal to a single fraction, both all over 6. So I know that the numerators must be equal. But structurally, I can show that by saying 6 divided by 6 is 1. So I end up with 7x plus 4 is equal to minus 24. Subtract 4 from both sides. So I end up with 7x is equal to minus 28. Divide both sides by 7. I've run out of space a little bit, but we can still say x is equal to minus 4. Now, in this particular case, I was asked to find the original number. I could have easily been asked to find both numbers. So in an English question, it is very important for our final answer to highlight what it is we have actually been asked for. Was I asked for this original number, the x, or was I asked for both numbers, in which case I would have had to say the next consecutive number was x plus 1 would be minus 3. So we need to be careful of exactly what we've been asked for. In this case, we were just asked for what we labeled as x. We weren't asked for our second number, but we could have been very easily. So it's important to keep track of what we were asked for. Now, next question. A mother is 3 times her daughter's age today. 2 years ago, the sum of half the mother's age and 1/5 of the daughter's age was 19 years. How old are they now? So now would mean today. So this information about the mother being 3 times the daughter's age is about now. So we're being told that information now. So we need to label these things. So I'm going to call the mother's age M, and I'm going to call the daughter's age D. So I know that the mother's age today, so M, is equal to 3D. So if I tripled the daughter's age, I would get the mother's age for their ages today. That's our first piece of information. So I've chosen what I'm going to label each of the people involved's ages as. I've given them a letter, and I've now written down my first block of information from the first sentence. Now this next bit is quite complicated because we have a change in years. 2 years ago. Well, what is the mother's age 2 years ago? If their age now is M, 2 years ago, if the age is in years, that means that her age would have been M minus 2. And the daughter's age, 2 years ago, 2 years ago, the mother's age would have been in M minus 2, and the daughter's age would have also been D minus 2. So whatever the age is now, minus 2 years, that is the age 2 years ago. So that is the ages that we're talking about in this situation, but we also have fractions to deal with. So 2 years ago, we now know how to label their ages. The sum of means we're adding our ages together. So adding, we're going to add stuff up for the sum. So we're adding up half the mother's age. So half the mother's age 2 years ago would be half of M minus 2. And 1/5 the daughter's age. So sum of, we're adding up 1/5 of the daughter's age would be D minus 2. And we're told that the result of this sum is 19 years. So that is our equation. Now, there's a problem because I have 2 letters in this equation, and I only know how to solve equations with 1 letter. But I also have the information that was given to me in the first sentence, that the mother's age is, the M in this equation is 3 times the daughter's age. So even though I'm dealing with 2 years ago, I've taken that into account by subtracting 2. I could substitute in 3D for the mother's age, and then I'd have an equation that only involves the daughter's age, which I know how to solve. So first of all, we have half of this. I'm going to write that as a fraction because it's easier for me to think about. Plus 1/5 of this. Remember, this is over 1, this is over 1, so top by top, bottom by bottom, I end up with the daughter's age minus 2 all over 5. That's equal to 19. Now I need to get this in one variable, in one letter, so I can say, well, the m here is the same as 3 times d. So 3d minus 2 all over 2 plus d minus 2 all over 5 is equal to 19. So now I need to get the, well, can I simplify my fractions? No. So I need to get the same denominator for all my fractions so I can compare them. So the lowest common denominator is going to be, well, that's over 1. So 10 is going to be my lowest common denominator of 2, 5, and 1. So I need to get a denominator of 10 here, so I'm going to need to multiply by 5 all over 5. 5 over 5 is 1, so I'm not messing with my equation, not breaking any rules of maths. Here I can multiply by 2 over 2 to get a denominator of 10. And here I need to multiply by 10 over 10 because I have a denominator of 1, and 1 by 10 is 10. So multiplying out my fraction, I get 5 by 3d and 5 by minus 2, so I end up with 15d minus 10 all over 10 plus 2d times minus 4 all over 10 is equal to 190 all over 10. I now have everything over 10, so I can start to add things up. So I have 15d minus 10 plus all of my second equation all over 10 is equal to 190 all over 10. Now I have like with like. I have tenths compared with tenths, so I can say this top line must equal this top line, or I can put in that 10 divided by 10, that doesn't look like a 10, 10 divided by 10 is 1, and 10 divided by 10 is 1. So I have 10 divided by 10 here. So I end up with 15d minus 10 plus 2d minus 4 is equal to 190. And now I'm solving for d, and I need to be careful. How old are they now? I also need to find the mother's age, but I need to do this first. So add up like with like. So I have 17d minus 14 is equal to 190, and solve for d. So I want d by itself. So 17d is equal to 204. Divide both sides by 17, and I get 12. So the daughter is today 12 years old. And we know the mother is 3 times as old today. It will be 3 times 12. So the mother is going to be 36 years old today, currently. So that is how we go through the process of translating our questions and be careful to keep track of exactly what we're asked for. And that is what we need for now.